Okay, so this second part of our ODE, that is the boundary value problem. So this is a typical question. If we analyze the question, so here we go, this is what we're going to get. So first we have seen this second order differentiation, the for the y with respect to t minus the tan y equal to 0. Okay, so this is a given equation. Okay, unlike the initial value problem, so if this is a boundary value problem, you now need to rearrange the equation to be first order relative equal to something. Okay, so please take note about this. Okay, let us continue to analyze the equation. So this equation, it gives the range of the t. So apparently d is the range of the t from 0 to 0 0.4. Okay, with the boundary conditions. Okay, apparently there is a boundary value problem because the boundary condition is given. That is, when the t equal to 0, we know that the y will equal to 0. Next, when the t equal to 0 0.4, the right hand side boundary, so we know that the y will equal to 1. So this boundary value is given. So very clear, this will be the boundary value problem. Please bear in mind that the boundary value problem will not always second order. It can be the first order as well. Okay, so the important thing is to read the question carefully to see whether the boundary condition is given. If the boundary condition is given, apparently it should be the boundary value problem. And let us continue to read the equation. Calculate the value of the yt when the step size h equal to 0 0.1 in 4 decimal places. So when you come on the table, so the table should be start with 0, next 0 0.1, 0 0.2, 0 0.3, and lastly 0 0.4. So this will be the thing should be appear in your brain when you analyze the equation. Okay, so please pause the video again if you need some time to read the question. So we move on to the next slide. It's a boundary value problem. So the first step, step 1, we place all first order or second order or both, okay, using the boundary value equation. So this is the boundary value equation that will be given. If you see these two equations, basically is the equation that's similar to what we learned before. So I would like you to pause the video to recall back. Okay, I hope you recall back what are the equations that we learned. Apparently this is a first order relative, so should be the differentiation chapter. And this 2 point or 3 point. Pause the video, write your answer on your paper before I tell you the answer. The answer will be the 3-point center. As you can see that we need 1 point after and 1 point before. So this involves 3 points. Even though the yi is no using, but the name for this equation is a 3-point center. So for this one, it's a second order derivative, second order differentiation. It also involves 3 points. Okay, also this is the 3-point center second order derivative equation. Okay, I hope you get the answer just now. So next, we go to here, the step 2. Step 2 is we need to rearrange the equation so that we can group the coefficient. Okay, so how are we going to group the coefficient in such a way that we will have this y minus 1, and then center will be yi, and then this one will be yi plus 1. So we have 3 terms in this case. Okay, here we go, the step 3, and then we need to list out all of them. So again, how we going to make it easier? That means we come down and then we substitute when the I equal to 1, then you will get this equation. When the I equal to 2, you will get another equation. When the I equal to 3, you will get the third equation. Okay, as you still can recall back that we have three unknown, am I correct? The y1, y2, and y3, because we are from y0 to y4. Okay, so to solve these three unknown, we do need three equations. Okay, and last step, our step 4, we can using the calculator to solve this simultaneous equation. Okay, so Thomas algorithm will know our scope, so that's why you can use your calculator to solve these three simultaneous equation, because we are assessing whether you are able to use the BVP numerical method. So here we go. This is the equation. This is a problem that we solving just now. Okay, so this is a table that should be appear when you analyze the equation. And then how the equation come out actually is as shown here. So step 1, we substitute the given finite differentiation the equation. Okay, so we substitute. So here we only have a second order, so we just need to substitute second order using the 3-point center second order derivative, as you can see here. So after we substitute that thing, as you can see here, minus the 10y to the same, and then we need to rearrange. Okay, as you can see here, we rearrange the equation. So this is how we can get the equation just now here. Okay, so the equation still in the general form, if you can see that. So that's why if you move to the next step in term of what? In term of substitute the I equal to 1, equal to 2, equal to 3, so that we can get the three equation here. So after we get these three equation, then of course we can represent in the matrix if you want. Okay, what's the benefit we represent matrix? If you can see here there is something that we need to move to another side, correct? Because it's not a coefficient for the y, so it will be good that you move or you represent in as that you learn in your chapter 2, the elimination method. Okay, so that you clearly show that what are the coefficients. So in general, there should be something, the pattern should be something like this. Okay, the A11, the A22, and A33 should be the same. Okay, so if you get this matrix, so apparently you are quite confident that you are doing something correct. Okay, and then after that you can use your calculator. Okay, these tips for you to key in your calculator, how you using the simultaneous equation mode, and then this is the answer that you should get. So please pause the video and get the answer in 5 minutes. After you get the answer, so this is the attendance summation task for you to get the attendance today. So this one of the question in your exercise, the equation is given. Okay, it's the first order derivative equal to something. And then if you read that, is we don't see anything about, if you read here, okay, so first you have a T, you have a TA. TA is a surrounding temperature, and then you have a K constant, and then find out somebody die, and then police came, and then get the body temperature of 27. Okay, and then the temperature of a house also assumed as 24, so that you know that the TA is 24. Okay, and then initial temperature, okay, you see the initial temperature is given. So apparently this is the initial value problem. Because the initial value is given, there's no any boundary value is given. Okay, so you know that the initial value is 37. K also given, so you can substitute that to the equation. Now the question asks you how long that the victim has been killed. Okay, and then also using the step size of 1. Okay, so 1 apparently is the 1 hours if you keep reading. And interpolation technique, you need to using the interpolation that you learn in your chapter 3. And then the last sentence tell you that the true time, this means the exact solution, the actual time is 9.522 hours. So you can compare the accuracy if you're using the ORS method to see how accurate if you try to estimate using that very straightforward numerical method. Okay, please pause the video now. Okay, I want you to pause the video now. You are required, I think you need maybe around 20 minutes to solve this problem by yourself. Okay, and then submit to the author as your attendance. Okay, please pause the video now. In the next slide, I'm going to show you the answer after you complete it. Let's say you complete already, so this is the answer. So you can see that, so you need to iterate the solution for 9 times. Okay, start with the initial temperature 37, and then if you can see that each time the temperature drop, so it is logic and correct because the temperature will drop. Okay, and then here this is the interpolation. Okay, even though the interpolation is now the main thing that you learn in this chapter, but you are expected to apply them as you learn already in your chapter 3. So what is the hint that I would like to give you is to apply the interpolation. We want to estimate this one. We want to estimate the time. Am I correct? The time. So in other words, the time will be our y-axis. Okay. So our y-axis will be the time. Okay. While the x-axis will be our temperature. Okay. Since the police, when the police come, police measure the victim is what is the dead body is 27, am I correct? It's 27. So it explains why we stop at 9 interaction. Okay, why we stop at the 9 iteration. Okay, because 26 at here. Okay, let's say this is the point of 9 iteration, 26.9958859, okay, degrees Celsius at this point. And then this one will be the 27.1442. Okay, so this is about the temperature T. Okay, and then the y-axis this time we make it as our time in terms of hours, T in terms of hours. Okay, so this capital T is a time T. Okay, so if you try to mark according to the given data, okay, we try to mark when the let's say this is a point, so is at 9 at here. Okay, Let me maybe mark a little bit. Okay, so this point and this the another intersection point right here. Okay, maybe I mark it here slightly far away. So for this is measure something like 27, correct? So 27 is between these 2 points, correct? 27 is at here. 0.0000. Okay, in 4 decimal places if you insert. And then when the temperature reach this 27, so it's at the time of 8. Okay, so it should be lower. Okay, so here is 9. Here is 8. Okay, so now we want to know that what is the time? I'm correct. What's the time when the temperature is temperature 27? So that's why you can using the simple interpolation to estimate it. As you can see here, actually it's a linear luggage interpolation, the coefficient of L, and this time is 8.7828. Okay, so apparently based on the visualization is logic. Okay, and then should be correct. Okay, I hope you get the right answer before you submit it. Okay, so I think that's all for this week learning. Okay, thank you very much.